In Personal Care's series of webinars. My name is Tim Probert and I'm the editor of Personal Care. Today's webinar is presented by X-Rite. X-Rite is a global leader in global color science and technology, helping brands achieve accurate, consistent color across every stage of product development. From formulation to final packaging, its solutions empower cosmetic companies and their suppliers to ensure color fidelity, streamline workflows, reduce waste, and deliver stunning, reliable color. The title of today's webinar is Unlock the Secrets to Consistent Color and Appearance in Cosmetics. In this webinar, you will learn how advanced color management is transforming the way cosmetic products are developed, approved, and delivered with flawless consistency. Today's presentation is given by Felix Schmollgruber. Felix is X-Rite's Europe, Middle East, and Africa Sales Director for Services. Felix studied printing and media technology at the University of Applied Sciences in Munich, in Germany, and started his professional career in 2001 at Greytag Macbeth, accepting the challenge to explore industrial color management in a variety of industries. After 6 years in sales at both Greytag Macbeth and X-Rite, Felix moved into the European headquarters of the freshly merged company in Switzerland to serve as technical support engineer and trainer. Here, Felix helped customers implement and troubleshoot X-Rite solutions. Felix then led a group of application and technical support specialists before in 2022 becoming X-Rite's EMEA Sales Director for Services. Well, with that introduction done, I'd just like to say that there will be a live poll immediately after Felix's presentation, and then we'll move to live Q&A session. So if you have any questions for Felix, please put your questions into the box on the right-hand side of your screen in the webinar system. And with that, over to you, Felix.
Thank you very much, Tim, and welcome to our presentation here. I'm very excited to do this because I didn't do it for quite a while, so I hope you like what we have to share. We're going to talk about some mega trends. We're going to talk about why to measure color in the first place, even though I'm assuming that many of you measure color in their daily life already. We want to address why color management really matters and what the complexity of it is. Then I give you some basics for those of you to whom the topic is completely new. We talk about some challenges, what X-Rite has to offer to overcome those challenges, and how we think we are going towards a digital future with color formulation, color evaluation, and quality control. And then we wrap it up with what we believe the essentials are. So with that, into the trends, we see, of course, now sustainability to be the big standard nowadays, right? Consumers getting more and more eco-conscious. They expect transparency in ingredient sourcing and packaging. They want still to have consistency because that's an emotional buying criteria. It's all about color with cosmetics. The demand for sustainability is actually also in favor of asking a higher price for the product. And of course, brands respond to those challenges, investing in reformulation, which is color critical, sustainable packaging, which is color critical, and of course, supply chain transparency. So sustainability is the baseline. The second trend we see is hyper-personalization. The use of artificial intelligence and virtual reality is ever growing for all kinds of products. Every customer, every one of us has a pocket computer in their hands typically, or in their pockets, which a lot of apps and a lot of digital content tries to gather our attention every day. And of course, in a cosmetics world or in many other product worlds, customers or suppliers want to have color accuracy on those devices and actually inspire the customers to make a purchase. So this also offers in cosmetics customized product formulations partly, or to enhance also the customer and consumer engagement. So personalization or hyper-personalization is really on the rise, as we see. And then, of course, the retail changes. Even though the classic physical store is still the place to go, we also have devices to measure skin tone color in the store to match foundations to that skin tone color. There is an ever-growing online sales happening, of course, and there is social commerce or platforms, as I just mentioned, also in context with the use of AI and VR, which is changing the retail space in cosmetics. So you want to have a seamless omni-channel experience, and that, of course, is all color critical across multiple devices, across multiple materials. Now, with that, let's think for a moment why one would even measure color in the first place. Because when I talk to people in my private life, they always say, well, what is it all about color measurement? I have two eyes, I can watch things, I can compare samples. Well, you cannot really, because we could discuss here on whether these squares A and B are the same or a different color of this famous Edward H. Adelson square. This is a scientist from the US who did this. And in the context, our brain is always trying to see context, and it's trying to enhance contrast. So it's trying to help us navigate through the world and not hit any obstacles. Now, in this context of this checkerboard and the green pillar on that board, the square A is associated to the dark squares and the square B is associated to the light squares. I think we can all agree upon that. Let me build the bridge between those two squares in order to show that the physical color is actually identical on A and B. And there is no trick with this. This is basically what it is. I can remove the bridge again, and you would see A and B potentially being the same color. And of course, as much as we can assess color visually with our eyes, it's hard to communicate. If I ask you for a name for this color, I'm pretty certain we get quite a big number of different answers. So I don't know whether you want to hammer a name or a specification for that color into the chat. I'm curious to see whether we get some feedback there. Is that possible, Tim and Alex, that people use the chat live now? Anyway, one thing is, we probably as an audience here find numerous different names for this color. The harder challenge is I ask you to memorize the color right now, because I'm going to move it away. And now I would want you to tell me which one it was. Any opinions there? Or make your own guesses, right? So what you realize immediately that it is very difficult to identify a color out of similars and memorize a color. Therefore, we have no color memory. If we have a bunch of similar colors, what all of these are from A to P, it's very hard to identify which one it was. So I can actually resolve this. It was number N. Here it is. That's the evidence. N was our color. So that is why we measure color and why we specify color by the numbers. And why does that matter? Well, it matters because you want to have brand identity and customer loyalty. So there is an importance of your signature colors. There is challenges with colors and different effects like metallic effects or transparency and certain textures. You want to reduce errors and waste. You want to maintain global color standards, enabling regional production and flexibility. And you want, of course, consistency across platforms. And you're limited by raw material restrictions and the need for reformulation if a raw material changes or has to be substituted. And all of that is something we can take care about. So in the end, it is about accurate hues across multiple materials and products, right? We want to have the same shade of white across all these products. And what that typically looks like is, in general, in a consumer products material workflow, we have typically different participants to the supply chain. We start with raw materials who are converted by advanced material manufacturers, such as the cosmetic manufacturers are. You actually have the intelligence of knowing which chemical combinations make a good skincare product or make a protection product. So you combine maybe chemicals of all sorts with pigments or dye stuff to color them into a skincare product. And then, of course, you need to, and you basically then either sell it to a cosmetics brand, or you are that advanced material manufacturer / brand yourself, and you end up having your product. Now, of course, this product needs to go into a container, which again might be pigments, dye stuff, and certain resins like plastic raw materials being processed into the advanced material, either plastic master batch, which is colored concentrate, or plastic compound, which comes with all the functionality, health and safety compliance, light fastness, whatsoever. Which then this plastic material is then molded into the container or is extruded into a tube or whatever. And then, of course, you get this from a rigid packaging manufacturer as the cosmetic producer, and then you can actually box your product. And then you put it onto distribution into the retail, and finally the consumer gets the product. But the big question simply is, do we really get that right? Because there is color variation and complexity all over the place. So what is that color management complexity? Well, color management complexity basically is that the reality is, or the ideal scenario is that your brand color goes onto your packaging in exactly the same shade, goes onto your functional packaging like this lipstick container, or even onto an application device which you might sell along with your product, and then also onto your packaging, right? And you would want to have consistency and the same color all across these different materials and products, which make your total assembly to a product you sell to your customer. Well, the real world, unfortunately, is that it's very often very disconnected. So we do not get color harmony right easily. And I will come back on why that is, right? Basically, typically designers use digital devices nowadays. So they have a computer screen and they work with RGB values or RGB sliders to do brand designs and web designs. And then you try to translate such an RGB value, which a designer chose on an uncalibrated computer screen, into a physical product, which is already very difficult because the physical product uses pigments and dye stuff to mix material color, which is a totally different color system than red, green, and blue values on your computer screen. And the story goes on. The product colors defined by a supplier based on any inspirational sample maybe do not match the brand, the text color, the brand color, sorry. That might be a textile sample or a thread of something which is the inspiration for the very lipstick product. And that's, of course, a very difficult sample to match. And then accessory color is again defined by another supplier based maybe on the same textile sample, but that supplier has to make a varnish which coats the wooden stick of this brush, which is basically a different chemistry than the plastic container which holds the lipstick. And finally, of course, corrugated board is printed on with printing ink, and printing ink is transparent. And if this is like a recycled brown craft cardboard, the color you might specify looks again very different on that box than your intention would be it to look. And we get back to this later to show you how we try as X-Rite to address these challenges. But that's basically the real world scenario. So with that, I'm trying to move into the basics of color measurement to give you a little context how color measurement works. So it's basically very simple. The color sensing process is consisting of three different things you have or you need for color to occur. Firstly, we need some light. Without light, there cannot be any color. Then, of course, we need an object which is illuminated by that light, and the object's physical property absorbs parts of that light and reflects other parts of that light, which make actually the color impression. But yet we need an observer who looks at this. So light is typically consisting of all the colors of the rainbow, as you can see here, and the orange basically only reflects or scatters back the orange portions of that rainbow, which gives us the orange impression into our human eye. The challenge with this is that this is a 3-variable system. This light is very variable. I have a different daylight today with bright skies versus having overcast skies. I have a different light in the morning versus the evening. I have different artificial light sources indoors and outdoors. So light is highly variable. White light is not always white. And that, of course, has an impact on what color looks like. The same is true for the object, which we want to characterize, which we actively control and color with pigments and dyestuffs, as we just discussed earlier. And as a matter of fact, it's also true for the human observer. So a human observer, we don't all see color the same way. And in order to resolve an equation with 3 variables, we need to actually set 2 of these conditions as constant. And we basically set the light constant and we set the observer constant. And there is an organization which is working on this for many, many years, the so-called CIE, who defined all that and who is our authority to arrive by this multiplication. So we multiply standardized light sources. We have a specification for daylight, for example, with the human observer functions, which are our rods and cones on the retina of the human eye, who have blue, green, and red sensitivity, like a computer screen produces color. And then we do what we call a so-called spectral measurement. So we expose light to a sample and basically measure through a spectrophotometer or a spectrometer. We diffract that light into the rainbow colors, and then we measure every 10 nanometers of wavelength a point, and we get a clear curve which represents exactly the reflectivity of that sample. So an orange curve, as you can see, absorbs a lot of blue and green light and then starts reflecting the light in the orange and red area. That's why an orange typically is such a step curve, as we can see it here on screen. Now, since working with those curves is rather complex, we convert and translate this equation into 3 values, which give us a 3-dimensional virtual system, which is called the so-called LAB color space. L for lightness, the A-axis or the X-axis would be from -A green to +A red, and the B-axis would be from -B blue to +B yellow. And around the circle, I would have all the hues of the rainbow. And in the center, I would basically have all the gray shades, right? So if I have a neutral gray, it would have a 50L, is the middle between 0 and 100, black and white. And I would have A and B 0 because I'm in the neutral gray area. The more colorful I get, the higher my A or B values get. And you see the orange maybe actually having LAB values of 65. So we are at mid to high lightness. We have an A value of 33. So we are away from the center point by 33 units. And we have a B value of 78 units, which is substantial. So we are clearly in the orange range here with this color. So here's some examples how we could actually determine such LAB values for different stuff, like for the packaging of a cosmetic, for the product, the cosmetic product itself. We could have LAB values now here with a -B value, since this is a purple, which is a bluish red, if you wish, or this kind of reddish or a salmon type, orange type color. We have again a positive A value of 30 and a positive B value of 54. Here is another one which with a pretty high lightness of 79 units, and again a very strong positive A value and just a little bit of a B value, which makes this a yellowish red, or basically a light red, if you wish. Now, with these values, we determine color spots in space. And if we have to compare 2 colors, the beauty is we get actually difference values. We get a delta L, a delta A, and a delta B. And from that, we can derive a so-called delta E, a color difference value. And those delta values help us understand the differences of colors. So if we look at orange A versus orange B, we might actually have a positive delta L, which means orange B is slightly lighter. Orange B might be minus delta A, so it's maybe less red, and it might be plus delta B, so it's more yellow. And the total color difference between 2 points in space would be called the delta E value. And that delta E value, as a rule of thumb, is whenever it exceeds a value of 1, we have a just visible difference. That's kind of the idea behind that. And knowing that, we can, of course, define tolerances for our color and make sure we have color consistency whenever we go and measure color. Nevertheless, there is also other challenges with color management and measurement, even though we are now able to measure color into a defined color space, and we can actually communicate color by the numbers. And those challenges are, we want to maintain product quality. We want, of course, to have formulation accuracy. We want to have a global supply chain which knows exactly what the targets are and how to achieve them. And we want to also translate our colors into digital tools and innovation, like we said, AI and VR, to have the color available consistently in a digital format. The problem with cosmetics very often specifically is that we have different physical sample conditions. So we do have loose and compact powders. We have lipstick and nail varnish where there might be solvents involved. So we have creams, liquids, and lotion. And of course, we have all different types of and shapes of packaging. And you can imagine that if you try to measure these first 3 conditions, loose and compact powder, lipstick, nail varnish, or cream, liquid, lotion, with an instrument which needs to touch the sample, you probably get your instrument contaminated quite quickly. And that's, of course, something we want to avoid. And you will see in a moment that we do have instrumentation which measures non-contact. Besides the different physical sample conditions, we also have different optical sample properties or conditions. Namely, we might have a difference between one and the same base black, but one part, for example, as you can see here, might have a glossy finish versus a matte finish. That's 2 different appearances, and that's basically 2 different colors for our eye. We might have the same in automotive or with leather products, for example, a textured versus a flat solid product, a bulky or powdery versus a solid product, a liquid versus a solid. And then in all together, you always have 3 different optical core properties, which is an object is either highly transparent, so you can perfectly watch through it, as you can see here to the left. It is on the opposite side fully opaque, so it's hiding everything behind it. And of course, there's also the condition in between, the whole range of translucency, that it's partly transparent and partly opaque. And finally, in cosmetics, of course, very common, we have effect colors where little aluminum flakes or mica flakes or flakes showing a color flopping behavior, or at least a lightness flopping behavior, are used to make more shiny, glossy, or sparkling type of effects. And such colors we also need to measure differently. And in order to cover all these different conditions, the optical properties, the industry is using 3 different measurement geometries. In a nutshell, in the center, you have the so-called 45 0-degree geometry, where we actually illuminate the sample from 45 degree of its perpendicular or of its normal, and we actually stare at the sample in the normal condition. And with that, we typically measure what we observe, because such a textured sample, as you can see it here, might scatter more light than the solid sample. So you might actually see a lightness difference on such a sample, or even on the glossy and matte surface here. The glossy sample would always look darker to the 45-0 instrument than the matte sample, because the matte sample is scattering light on its surface. Now, in order to run a formulation, the industry developed a geometry which is called the so-called sphere geometry, or diffuse 8-degree geometry. Here you have a diffusing sphere. It's a sphere ball which has a white coating inside, and you illuminate that sphere from the outside, and then on the bottom of the sphere you have the aperture hole, and due to the white coating in the sphere, the light's bouncing around, and you have a perfectly diffuse light in that sphere. And with that, you have the ability to measure these two different surface conditions independent of their surface conditions in the diffuse environment in order to get the color formulation right independent of the surface. That's very frequently needed if a customer comes with a sample made of one material and wants to match that sample in a different material and just want to get the color right independent of the surface. If you would get a sample and you are supposed to produce a plastic material based on the glossy sample, you might actually formulate it too dark versus if you would measure the matte sample if you do not have an instrument which can eliminate that difference. The multi-angle instrument, as you can see here, has one or two illuminations from two different incident angles and has typically up to 6 receivers. And if you illuminate one lamp after the other, you can basically get 12 different measurement angles because those samples would look different under different viewing angles. So you need to measure them accordingly under different measurement angles. And with that, there is a whole portfolio of different instrumentation and software, as well as a light booth for visual assessment, which we will cover in the next section. But let's go back to what I showed you earlier, right? This supply chain consisting of the different participants, raw material manufacturers, advanced material manufacturers, OEMs and brands, etc. There's huge complexity here across those different materials, sample conditions, and optical properties of those samples. And remember, we just looked into the ideal scenario where everything is in harmony versus the real world scenario and why these things go wrong. So let's now unravel how we believe we address this and how we actually successfully address this in many industries already. Now, from the ideal scenario to the real scenario and how to turn it into the ideal scenario. Well, firstly, if you start designing and specifying and characterizing brand colors, you should do this by using a common language of color. And we, of course, as Pantone is part of our company, always recommend to go from Pantone colors because they are widely known in the industry, especially in printing, which was the origin of the Pantone matching system. And we have them digitized for all different conditions by now. So you can use Pantone colors. You can actually calibrate your computer displays with a monitor calibration device. Here, our i1 Pro 3 device, which is also from us. So we've also been at the forefront of developing all the tools the graphic arts industry originally used and which nowadays is widely used by all type of designers, whether it's textile or industrial design. Everyone's working on a digital device. And if you want to make color critical decisions, you should firstly have a very good monitor and it should be color accurate. And that can be ensured by profiling the monitor. So here's a device which measures systematic RGB color swatches and then converts them or translates them into neutral LAB so you know exactly what your monitor is doing. And here you see a light booth, our Judge LED light booth, which we go into more detail later on, in order to have consistent viewing conditions in terms of standardized lighting that you can also translate or compare physical product with the digital reality and the digital creation you have done. Then, of course, if you want to get your product container right, you can extract from your Pantone reference brand color a so-called color exchange format file, which our color matching software can read. So we actually can inherit a Pantone color as a spectral color into our software, and then we can actually do computer-aided color formulation at the click of a button. You will see later how this works as well. And from that, of course, we can get our material, our product material color right by also matching it towards the same reference, transferring that CXF further down the supply chain. And of course, we could also share that spectral color data with any accessory manufacturer as well as with the packaging manufacturer. Now, of course, we can also do process and quality control with the connected, or basically the QC part of the matching software, along with a light booth to really monitor and control everything. And then, of course, we can also globally report that. And since we have two business units, we also deal with the printing, ink and printing and packaging printing world. We can use the very same Pantone color to also get an ink match right based on the substrate we want to print on. So we can consider the brown craft to be the base material and adopt the ink to really get the closest harmony possible. So here is how we get it right. Now, coming back to the spectral measurement for all the physical conditions of our samples, I had talked about an instrument which is a non-contact instrument. This is our MetaView. Our MetaView is a hyperspectral camera instrument, so it measures the sample non-contact. You would not touch any part of the instrument, and you can actually present either flat or bulky material to the instrument without contaminating the instrument. And since it is a hyperspectral camera, you could even pick and choose down to a 2 millimeter, as small as 2 millimeter spot, a specific targeted area in order to assess the color you are measuring. Then, of course, in cosmetics, we very often see effect pigmented product, which has a certain sparkle effect or a color flopping effect. And for this purpose, we have the multi-angle spectrophotometer MA-T12, the multi-angle MA, and T for texture, because that instrument also has a specific camera system computing multiple camera images to even characterize and assess those flakes and those special effects, which we then can even visualize in a virtual reality world or in an artificial intelligence world for digital devices and digital output of the physical product. And this is actually the next level of color management, which we are driving for the last 10 years already, and it's growing more and more. We made the CXF format, the color exchange format, as a color communication tool, as the PDF of color already in 2005, and it turned into an ISO standard even in 2015. And we are on the journey to now expand color into appearance, because appearance is more than just flat color. Appearance is spatially varying reflectance distribution. So it's all these different conditions, like an embossed leather or a gold with a certain surface texture, or a silk of a tie, or these effect pigmented stuff you are also using in the cosmetics world, or even a volumetric model with a specific level of transparency, like any plastics materials. All these properties can go into an AXF container, and that AXF container can also be used for digital outputs of all sorts. So these two things, the non-contact instrument and the multi-angle instrument connected to appearance, are really at the forefront of innovation at this point. Then, of course, we have standard instruments. Such instruments are out there in the market for many, many years, like a benchtop sphere spectrophotometer, which is the most accurate instrument you can get, has the highest inter-instrument agreement. And that's, of course, a necessity if you want to eliminate the transfer of physical samples across the globe. Because if you want to do color by the numbers, then, of course, you depend on a highly accurate instrument fleet, which you can achieve with such instruments, and the tool we call Net Profiler, where you can even profile and monitor those instruments in a fleet management environment. Of course, we also have that sphere geometry as handheld instruments, which are also widely used in the cosmetics industry, because you can actually carry the instrument to a sample if necessary and not the other way around. And from the software perspective, we have basically two very interesting tools. We do digital color formulation. So we have software where we can characterize all the colorants and pigments we are using as a calibration set. And then we can literally measure or pull any reference from a cloud database and click at the click of the button, get a recipe within seconds which tells us how to compose different ratios of pigments and colorants to a recipe which will match our reference color. And the benefit of that is that this is actually needing much less steps than if someone does it manually. It's you get the always 100% correct pigment loading, which is basically a cost-saving element, because if you overuse pigment, which is a very expensive ingredient or raw material, then of course you waste money. You can reproduce a recipe and correct it also for substituting pigments within quick minutes. And you basically get your overall cycle time to match a color is considerably lower than if you do it by hand, even if you have very experienced colorists. So how does that work? You basically have an instrument, you measure your customer sample, or you recall it from the database. You then have certain sorting criteria by which you want to have the combinatorial recipes output to you, and which determine what the best recipe is supposed to look like. Then you formulate, which is seconds to minutes at the maximum, and then you can review the results and choose your recipe of choice, produce a verification sample, measure the verification sample against the standard, and if you're happy, then you report the recipe and get it into production. If you're not happy with the result, then you basically go in iterations and correct the color until you're happy. And as I said earlier, with the computer, you reduce typically from 10 to 15 steps down to 1 to 3 steps, depending on how accurate your calibration setup is. Now, if you do that, measurement, of course, is always a good check and the neutral source, but many customers, of course, still rely on visual evaluation. So they still want to have a final call by using a light booth. And the latest product of ours is the Judge LED, because the EU banned the fluorescent tubes as of February this year. And now we have brought an LED-based product to the market, which is very nice because it has a very homogeneous and bright light distribution. And you can see here from the small images that we have different choices of light. D65 is the representative of standard daylight. D50 is Northern Hemisphere daylight. You have various store light conditions and of course home or warm white lighting conditions as well. And you can see those two blue and red items basically look different under these different lights. And we can consider that in the light booth as well as with the measurements we do. So that is kind of the overarching portfolio of solutions X-Rite offers to this market. And therefore, I'm already at the end and want to remind you for the essentials of digital color management, which we believe are, you need to have specified measurement conditions. You should have aligned and accurate color measurement instruments, which you can control in a fleet management. You should have one central digital library for your color references, that everyone's going into the same direction. And you should, of course, have protected and traceable data carriers like file formats like CXF or AXF. It's a difference if I communicate a set of LAB values versus communicating the core spectral data behind it, which instrument it was measured with, whether the instrument was in a good and calibrated condition, which aperture was used, how the sample was placed. All these specific elements we actually control in a traceable and audit trail type format with our software products in order to really make this seamless, consistent color workflow across multiple materials possible. So you start with digitizing the inspiration by choosing color references you can easily communicate. Then you basically digitize the color and put it on a cloud database, and then you can actually refer to it in a specification document, and you can pull those references from a central database, run your matches, and do your production and process control, and of course use a light booth to control the final results when you transfer back from digital to physical or the other way around. And with that, I'm already at the end of the presentation. We would have one question to you. So we invite you to contact us if you're interested in more information. And we would now like to launch a poll question with the webinar tool. And we would appreciate if you would answer that to us so that we have an idea whether you liked what you've heard about in the last 40 minutes. So I think the poll is live for about a minute or two. Okay, you remember the color memory quiz when I asked you to name the color? We had a vote for deep purple, we had fuchsia, we had magenta, we had pink. So you see, communicating color by a color name is not trivial, is not an easy task, right? And I'm also seeing now that we had a couple votes for different letters when I actually pulled that color next to similars. It's typically a random success if someone really chooses N, which the color was.
Hi, Felix. Yeah, with a few more seconds for the last few people to vote. Yeah, that's a very solid response. Nearly 60% of you voted so far. Be great if the rest of you could respond. Felix, this excellent presentation.
Thank you.
And we've had a few questions in about the the slides and the presentation. Just to remind people that there will be we will be sending out an email in the next few days if you missed any of it or want to watch it again. People that have registered will get the full recording. So just to head off those questions that we've had already in. Okay, I think that's we're done now on the voting. So just bring myself in here and we'll go through some of these questions. Thanks again for a very interesting presentation. So loads of questions, which I love to see. Okay, firstly, one from Amir that came in early. As a cosmetics company, we care for multiple color-related parameters: color, opacity, the change of color during drying, brackets, oxidization. Does the CL7000 series allow such diverse set of measurements for liquid foundations, and if so, how?
The 7800 is our benchtop instrument. If you allow me, I'll quickly jump back into the slide for the audience to see what that is, which is here. You see that? And yeah, I've just put a picture on here with a fraction of the available accessories. So if you have liquids, we have also the opportunity to either put the instrument port up, like we call it, that you could drop a Petri dish on top of the instrument. I had a Petri dish here on the slide when it came to instrument to measurement conditions. This here in the top left corner is a Petri dish. So we do have accessory where you could put the instrument port up or even port down, that you could actually put something from below to the instrument aperture, and then you can measure such conditions. In our software, you can also, and that's a very nice feature, you can do timed measurements. So you can do a cadence of 1 to 2 minutes, 1 second to 2 minutes in second increments to define, I want to do 200 measurements every 10 seconds to, for example, track and monitor how drying or curing has an effect or an impact on color change. And then you can translate those findings into wet to dry comparison measurements to make you faster in QC. That's also a very common use case we have with our non-contact instruments. It's a very, very good question. If you're interested in more detail, happy to have an individual conversation.
Yes, thank you, Amir, for that. Okay, next question from Hugo Mendez. Hello, focused on non-flat metal surfaces packaging, where we can see a deviation with the naked eye, but is already formed and we cannot measure it with a spectrophotometer. For example, a difference between the lid and the body. How can we control this when we receive the packaging at our factories? Does that make sense?
It makes sense. We do have for the CI6X, and you see one fraction of that accessory, that's the Sphere handheld. We do have an accessory which we call the metal can or rounded shapes type of holder, where you can basically compare round to flat shapes, even metallic ones, if you can reduce the aperture to a minimum. And you could also use, for example, the MetaView to choose a very small spot here to accomplish that. So you can compare within limits, to be fair, but you can compare flat to round objects. Especially when you visually see it, the instrument would always see it as well. And you could actually make a study to define the right set of tolerances to avoid these things before they happen.
Okay, good. All right, that's huge. Thank you very much. Yeah, we've got loads of questions coming in. They're sort of flying in, so this is great. So a question from Daniel Alejandro Peña Camargo. Can I measure gloss with the CI64 spectrophotometer?
That's a good question. The CI64 does measure what we call the correlated gloss, because we have two measurement modes, as I said. So this is the CI64. I'm jumping back and forth if you don't mind. And this is the diffuse 8 geometry, and it has two modes called specular component included and excluded, which I simply labeled here. I can measure with or without the impact of surface. As a matter of fact, the CI64 is measuring these two modes with the impact of surface and without the impact of surface simultaneously. And with that, we can compare these two readings and make a so-called correlated gloss assessment, which is valid for high matte to almost, well, if you're familiar with gloss measurement, a gloss measurement or gloss units range from 0 to 100. And with the correlated gloss feature, we can measure from 5 to very matte to about 80, 85 gloss units, almost high glossy, but not the full range. That would need a dedicated gloss meter. I can actually share this. We have currently a new handheld instruments in the works where there will be a real gloss measurement integrated. We can measure real gloss with the MAT12 though, which we use for the metallics measurement, because the multi-angle geometry, as you can see it here to the right, is allowing us to do that.
Okay, good. All right, thank you, and thank you for that question, Daniel. Question from Kelly Dobos, who is well known in the industry, I think, and I know that she's contributed to personal care, American professor, I believe. One of the challenges we have in the cosmetics industry is the variability batch to batch in the pigments themselves, the variability batch to batch in the pigments themselves. What is the best way to measure individual pigment color for batch to batch consistency in dispersion or powder form?
How we do this normally in all the industries is we do a so-called color and strength assessment. And in order to do that, you need to produce a sample against a calibration pigment, which is typically white. So you need to have a laboratory batch of a white pigment or a white base material where you would actually mix defined percentage into. So you would, for example, make a 5 to 95% mix, 5% your pigment to be assessed versus 95% of a white base material. And you would specify that as your 100% colorant, relative colorant strength level. And whenever you would have the next batch coming, you would use the same ratio, 95% of this very same white base with 5% of the new batch. Will produce a mix, and the color measurement would immediately tell you whether you are higher in color and strength, so you could get 102, 103%, or lower in color and strength, 98, 97, 95%, which typically makes this batch to batch variation for one pigment type, because the root cause of that is grinding or milling the finer a pigment is grinded or milled, the more surface you have, the more color and strength you have. Unfortunately, you cannot determine color and strength in the bulky condition with the pigment itself. You need to mix it in a media which actually shows the impact on how it would disperse. But that's a very common thing to be done when you want to maintain and keep your color formulation system accurate, because you can imagine if your color and strength based to your reference is 103%, you would need to use less of that batch, systematically less in any recipes than if it's weaker than the original batch, when you would then need to use a little more to compensate for that color and strength variation.
Okay.
I hope this is appropriate answer.
Very much so. Okay, and I hope you're well, Kelly. So thanks for your question. Next question from Paulami Das. How does digital color formulation work? I mean, if I submit a lipstick sample and a lipstick base, will it be able to tell me which colors and in what ratio to add in my base?
Yeah, I didn't go into that detail. What we typically do, we need to, so it works by characterizing all your available colorants with systematic mixes. So in other words, if I have a red or 2 different types of red pigments, 3 yellows, 2 greens, 2 blues, whatever, as a base set, and I have a base material, a white or a clear, I would basically produce mixes of 0.1%, 0.5%, 1%, 2%, up to whatever the maximum pigment loading typically is, which I would use for optical properties. And I would produce 5-6 samples per each of these colorants and would teach them into the software, typically on a contrast card, on a black and white card, so that I also determine transparency or hiding power of those colorants. And once I have this done, this is a one-time effort. I can really measure any individual color, and the math model in the software will be able to combine the optical properties I've taught into the software of every individual colorant to find the right ratio of those available colorants to match that color best possible. We have actually webinars out there on YouTube and on demand on our webpage where we explain this in more detail if you're interested. Or of course, you can always contact us.
Yes. And your contact details, are they on the slide somewhere? Are they there somewhere?
I put my link to LinkedIn on the very last slide. So if one wants to reach out to me personally, this is my LinkedIn profile. And of course, our company profile. So I can be found. But we are happy we probably cannot cover all the questions, but I know that we're going to get them, and we are happy to address every single one of them.
Good. Well, we have a few more questions that we don't have we don't have an endless amount of time, but let's rattle through them. Similar question to Palami's. Can we use your tools to create a centralized digital color library for faster approvals and fewer physical samples?
Absolutely. And I didn't go too much into the details there. We have a product which is called the so-called Pantone Private Library Manager, because of course we started off with putting our Pantone colors and our Pantone references into the cloud and make them accessible. And with a partnership in the ink industry, we even did that for different substrates for printing ink, because printing ink is always transparent. And a Pantone color from the Pantone book, you can imagine, looks very different on different types of paper substrate if those have a color themselves. Now we took it a step further and allow customers to use that environment to create, with our support, their own core central digital libraries and even run approvals through those. So that is like the advanced level really of color management, if you can centrally combine everything into one database and even submit approvals and get automatic approvals back. If you, for example, have a supply chain across time zones, that's a very convenient thing to do. And it's, of course, traceable and trackable. We even have scorecarding. So we can, in certain industries, we offer a so-called scorecard service where a brand company could monitor the reproduction of their core brand colors across multiple suppliers and materials to really have an assessment on whether Coca-Cola Red is always Coca-Cola Red, for example.
And you mentioned across time zones. We have a question here about, we're planning to scale manufacturing to new regions. Can X-Rite help us ensure color consistency across all sites?
Absolutely. We consider ourselves a global company. We have sales and technical support and marketing subsidiaries in 17 countries. We have certified service partners in 48 countries. We have I'm working here in our European headquarters in Regensdorf, Switzerland, which is close to Zurich. We have an R&D and service facility and a sales office in Munich, Germany, in the UK, in Paris, France, in Florence, Italy, in Singapore, in Shanghai, in Tokyo, and our global headquarters in Grand Rapids, Michigan in the US, as well as subsidiaries in Argentina and Brazil. And of course, we have a certified partner network of sales partners and distributors who are familiar with our solutions. And we have a solution architect team, which will be the right team to talk to get such an implementation going.
Very good. Okay, well, we've just got 2 minutes left. I've still got things coming into the question box. But maybe take 1 or 2 more. I'm sorry if we don't get to answer your questions, guys. But Sachin asks, what are the major measurement challenges faced in evaluating cosmetic colors, especially for pearlescent and metallic type shades? What are the major measurement challenges faced in evaluating cosmetic colors?
The major challenge is basically the method to apply it onto a sample carrier. So we've seen such samples being applied on, because skin is, of course, highly variable and skin is translucent. So, of course, you could apply a product to skin and also then place the measurement instrument on top of it. But for a for those pearlescent or for such effect colors, like I did call them in the slides, you are best off by using a multi-angle spectrophotometer because you have that gonio apparent effect, right? These colors might change at least their lightness, if not their color. So they are so-called color floppers when you observe them from different viewing angles. And to measure them, you should apply them to a flat surface and you should be able to put the instrument on top of it. We do have a specific cosmetics jig for our MA instrument. I'm going back to showing this jig for the sphere instrument. The MA instrument was this instrument, the MAT12, and we have a jig which we have for the non-contact instruments where we have these drawers and these spoons where you can fill product into, which can also be used for the multi-angle instrument. So the challenge basically is the sample presentation to the instrument, because if you measure a sample from different viewing angles, then of course you need to consistently present the sample to this arc of geometries in order to get consistent readings.
Okay, good. Okay, thank you for that, and thank you for the question, Sachin. Well, that's the hour up. Thank you very much indeed for your time, Felix. It was very interesting and thorough. And
thank you, everyone, for your attendance, and thank you for having me.
Thank you, and I'm sorry if we didn't have a chance to answer all the questions, but I think we did as best we can. So, as I say, if there are any more questions, you can approach Felix directly via the contact details. The slides, the presentation will be sent out to you in the next couple of days. And thank you very much for attending, and see you next time. Thank you. Bye.
Thank you, everyone.